Storm drainage system. This topic is about the storm drainage system. So sa picture, makita niya yung bahay, tapos yung drain niya papunta sa sanitary sewer. Yung storm drain naman, ito yung mga sa kalsada o galing sa bubong. Ito naman galing sa bubong papunta dito. Normally, ang didesign natin is yung paikot lang sa bubong, sa bahay. Yung mga drainage yan. Ito kasi sa labas na ito, is civil works na yan. Ito lang tayo. Tapos yung ano mo, then, tapos dito sa spacing, yan yung tawag dito, may spacing dyan. So hanggang yan lang ang plumbing. So paglabas na dito na, receivables na, sanitary na yan. So normally hiwala yan pag may centralized kang treatment plant. Sa atin is septic tank. Tapos ito, pwedeng isa lang to. Tapos yung dumi ng bahay nyo, yung mga human waste, tadaan septic tank, tapon dito kung allowed. Kung hindi allowed, papasip-sip mo yan. Mayroong 3 years yata pagpasip-sip niya. Ito 5 years, depende. So, storm drainage system. Stormwater is considered to be rainwater, surface runoff, groundwater, subsurface water, or similar clear liquid waste, exclusive of sewage and industrial waste. So, concentrate tayo dito sa drainage sa roof. Rainwater. Ito yung gutter, tapos punta dito sa downspout. Downspout niya, ito yung vertical. Ito, normally tawag dito is leader. Ililid niya papunta dun sa ibang location. Okay, meron kasing sa may ibang reference, ang leader, downspout, isa lang. Pero may ibang libro, dinescribe yan na itong leader. Tapos, sa loob, pag ito sa loob, ang tawag naman doon is conductor. Pag sa labas, downspout. So, storm drainage are required for roof areas, courtyards to collect storm water and discharge the storm water to an approved point of disposal not in conflict with other ordinances or regulations. Yung mga regulations natin. So, for roof areas, courts and courtyards, so ano lang to, meron sa mga trench drain sa ground to. Itong sa roof, dito ang topic natin. A roof drainage system is a system that is installed on the roof to divert water and debris of the roof. The drainage system starts at the roof line, and then you have the roof drainage to ground. The components that you need for a roof drainage system is a gutter system and downspout. With these two components working together, water is able to be removed from your roofing system easily. Yan, kaya kahit mechanical kayo, alam niyo yung itsura ng bubong. Mechanical na magpa-plumbing, yan, alam niyo dapat ang itsura ng bubong. Mga terms niyan. So, roof drain. Ito yung roof drain. Para siyang floor drain na may takip. Kasi protection yan sa mga dumi. Mga dahon yan. A drain installed to receive water collected on the surface of a roof and to discharge it into a leader, downspout, or conductor. So, di ba yan, leader? Ito yung horizontal drain. Pag maikli lang, so nandiyan lang, yung leader lang yan. Pero pag nag-extend na yon, ang tawag na doon is horizontal drain. So, mag-sizing mo na lang, dyan is for horizontal. Leader, a pipe connected from building gutter or roof drain to the downspout or conductor, di ba? Yan. Definition. Kung makita ka sa Google o sa Yahoo, sa internet, na ang leader niya nakatutok dito. So, kaya i-verify nyo lahat na nakikita nyo sa internet, ha. Mas maganda tingnan pa rin yung mga books. Downspout, a vertical pipe to convey rainwater. Yan. vertical pipe. Hindi pwede maging downspout kung rusak na. O maka-inclined. Diba? Kaya tinawag yun na leader. Rainwater piping shall not be used as soil, waste, and bent pipes. So, mga importante lang itong nilagay ko dito. Kasi may iba kasi isasama doon sa septic tank yung papunta sa ano. Hindi. Yung mga waste, yung iba, yung waste lang, and bent pipe, yung mission yung waste, itatap doon sa downspout. Okay lang yung iba, pinapayagan naman yung mga floor drain lang. Pero pag soil pipe, wag. Bypass na yon. Hindi nadadaan ng ano yung septic tank, yung mga human waste. Pero kung mga floor drain lang, okay yun. Tubig lang yun na yung mga basa-basa lang yun na pumasok mo. So, sizing of rainwater piping from Revised National Plumbing Code of the Philippines. So, saan yung table 11 that's one? Ito. So, ito yung binanggit na table 11 that's one. So, vertical rainwater piping shall be sized in accordance with table 11-1, which is based upon maximum depth and millimeter of rainfall per hour falling upon a given roof area in square meter. So, normally, a 102 mm per hour rainfall intensity is used around Manila area. Okay? So, saan yung pinakamalapit sa atin is yung Manila. Kasi yun din ang mga evaluator din, siyempre, mga Pilipino rin yan. So, ang gagamitin natin din is 102 mm per hour or 4 inch per hour. Rainfall intensity per year. For a year per hour. Ayan. Average yan. Where vertical walls, ano yung vertical? Ano yung yan? Roof area. Yung flat roof. Ayan, isipin mo dyan, yung flat roof area, o yung normal doon sa land. So, other than roof area, meron yung mga walls, may effect yun, i-add mo doon sa equivalent catchment area. Yung magiging tawag doon, catchment area, kasi yun sasalo ng mga tubig. So, where vertical walls project above a roof, so as to permit the stormwater to drain to adjacent roof area below, the total roof area considered may be computed as follows. A, for one wall, pag meron kang sa roof, mayroong wall, add 50% of the area of the wall to the roof area. Letter B, for two adjacent wall, magkadikit, add 35% of the wall areas to the roof area. Total wall area is 35% mo. C, for two walls opposite each other and of the same height, add no additional area to the roof area. Yeah. Letter D, for two walls opposite of the differing height, add 50% of the wall of the area above the top of the lower wall to the roof area. Ano same na siya ng letter A. Kinuha lang yung difference. Okay. Kasi opposite naman yung wall. Walls on three sides. Add 50% of the inner wall below the top of the lowest wall. Plus allowance for the area of wall above the top of the lowest wall per item B and B. Yeah. F, walls of four sides. No allowance for wall areas below top of lowest wall. Add for areas above top lowest wall per item A, B, C, D. Wait. Okay, walls of four sides. No allowance for wall areas below top of lowest wall kasi pantay-pantay yan. And for areas above top lowest wall per item A, B, C, A, B, D, and E. Yan. So may discussion dito. Discussion. G, the area of the side of a tall building exposed to rain is taken as 1/2 of the gross area. Kung may katabi kang building, computer, isama mo rin yung babalik na hangin doon. Hangin, ulan. So, for the following examples, so ito yung discuss na. The flat area of the roof will be given as 500 square foot. So, English yun ang example natin na hindi ko na kinonvert. And the typical wall area represented by each wall segment will be given a height of 10 feet with a width of 20 feet, which is 200 square feet. So letter A, for one wall, add 50% of the area of the wall to the roof area. So example number 1, a single wall projecting above the roof would add 50% of the total area of the wall, or 100 square feet, to the flat area of the roof. So yan, the total projected area would be 600 square feet. Diba? 500 plus 1/2 of 200 is 100 is 600 square feet na. This amount would then be used to determine the size of horizontal drain, gutter, ductor, or gutter. So yan. Ito ang gagamitin mo doon sa table. Tawag doon is total projected roof area or catchment area. So for two adjacent wall, add 35% of the wall areas to the roof area. Example 2. Using the same square footage as above, there are two walls of equal height with the sum of 400 square feet. Because the walls are adjacent next to each other than opposite each other, only 35% of 400, which is 140 square feet, will be used in the total square feet. Total projected area, roof area is 640 square feet. So 500 plus 140 is 640. Would then be used to determine the size of the horizontal drain, gutter, conductor, and tawag dyan tributary areas. In computing the area of adjacent wall, letter B pa rin to. Now, in computing the area of adjacent walls of equal height, it has been determined that all of the wall areas of adjacent wall, whether one wall is longer than the other or not, should be used and computed at 35%. Kahit anong mag-equal siya o hindi, basta pantay. For example, if one of the walls above was 30 feet wide, the computation would be 10 times 30 is equal to 300 plus 10 times 20 is equal to 500 times 35. So 35% is 175 square feet. So yan. Yung isang wall, 300 square feet. Yung isang wall, 200 square feet. So 500 ang total. Then 35%, so 175 square feet. So hindi equal yung wall. Okay. So example 3. So ito yung example T. Iba naman to. Pero ito B pa rin. Kinumbine na yung A and B. In computing the area of adjacent walls of an equal height, use the method used in example 2 for the adjacent wall areas that is of equal height. The remaining wall area above the area of equal height will be calculated as an example 1. So in example 3, two adjacent walls of equal height, wall sections 1A and 2. Adjacent siya. So, yung lampas doon, iba naman yun. Are calculated as 10 times 20 plus 10 times 20 is 400 square feet times 35% is 140 square feet. Now, the area above the equal height wall section is 10 by 20 or 200 square feet. So, would be calculated at 50%, which is 100 square feet. So, add this to 140 for a total of 240 square feet. Then the total projected roof area of 740 square feet, kasi 500 plus 240. Okay? Would then be used to determine the size of horizontal drain, conductor, or gutter. Okay, kung may pinadala sa inyong elevation, makikita nyo itong mga roof. May mga parapet yan. Makikita nyo doon. So, pag sinama nyo, mas detalyado yung calculation. Okay? Kasi may mabusising yung mga evaluator. O, ba't di mo sinama to? Ba't di mo sinama to? Sa calculation. Yung iba, hindi mabusisi. Tatagapin lang yon, lalagay sa mesa niya, tapos nag-comply ka na may analysis ka. Ito C. For two walls opposite each other and of the same height, and add no additional area to the roof area. Set up. Since they are equal height, equal area, so zero tributary areas. Add 100% of the add to 100% of the roof area. So wala kang i-add. So in example 4, two opposite walls of the same height will cancel each other. One wall will catch rain, adding to the rainwater on the roof, while the other wall will block the same amount of rain from falling on the roof. Therefore, no area is added to the 500 square feet of the flat roof area. Now, for two walls opposite of differing height, add 50% of wall, letter B, above of wall percent. Add 50% of wall of the area above the top of lower wall to the roof area. Okay. As in example 4, so also in example 5, itong figure natin. So magkaiba yung height niya. So sa taas mo 50%, yung ito 0 na. So the two opposite walls of the same height will cancel each other. Wall sections 1 and 2A. Wall section 2B is higher than the other wall and is calculated as if it was a wall by itself. So no wall opposite and no wall adjacent. Therefore, 50% of the area of the wall section 2B is added to the flat roof area. So using the same numbers, 10 times 20 times 50% would add 100 square feet to the total flat roof area of 500 square feet for a total of 600 square feet of projected roof area. This amount would then be used to determine the size of horizontal drain, conductor, and gutter. Letter E. So walls on three sides at 50% of area of the inner wall below the top of the lowest wall plus allowance for area of wall above the top of the lowest wall per item B and D. Example 6. So ito yung wall na binabanggit dyan. Walls on three sides na iba-iba yung height. So dito, hanapin mo yung magkatapat siya, di ba? Equal. So matitira is 2A. So this is, since isa lang to, 50% siya. So ito, adjacent, so 35%. Kahit pantay siya. So itong natitira, 50%. Manya. So for example 6, in order to determine the computation of the square footage that is added to the total projected roof area for the three walls of differing height, use the same criteria as in previous example. For example 4, the two opposite walls, wall sections 1 and 3A cancel each other. For example 1, the inner wall section 2A will be calculated as one wall since wall section 1 and 3A have been cancelled at 50% or 100 square feet, as in example 1 above. Wall sections 2B and 3B are adjacent walls of equal height and will be calculated as example 3 at 35% or 140 square feet. Wall section 3C will be calculated as example 3 as a wall section above adjacent walls at 50% or 100 square feet. A total of 340 square feet must be added to 500 square feet flat roof projected area for a total of 840 square feet. This amount would then be used to determine the size of the horizontal drain, conductor, or gutter. Ayan. Milito ito ba? Ano pa pala? So, walls of four sides. 1, 2, A and B. 3, A, B, C. 4, A, B, C, D. Yan. So, wala ng 5 sides up, pentagon na yun. No allowance for wall areas below top of lowest wall and for areas above top lowest wall per item A, B, D, A, B, D, and E. Example 7. In order to determine the computation of the square footage to be added to the total projected roof area for all walls of different height, use the same criteria as in the previous example. Wall sections 1, 2A, 2, 3A, and 4A are of the same height and opposite each other, and therefore will cancel each other, as in example 409, mo yung opposite na, bago yung adjacent. For wall section 2B and 3B, the two are opposite walls and cancel each other. Wall section 3B will be computed as one wall standing alone at 50% or 100 square feet per example 1. Wall section 3C and 4C are adjacent walls of equal height and will be computed at 35% or 140 square feet as example 2. Wall section 4D will be computed at 50% or 100 square feet as example 3. Therefore, a total of 340 square feet will be added to the 500 square feet flat roof projected area for a total of 840 square feet. This amount would then be used to determine the size of the horizontal drain, conductor, or gutter. Although roof drainage sizing may seem complicated, it can be very simple. Just remember that if the wall is standing alone or above the other wall, add 50% of the wall area to the flat area of the roof. If the walls are adjacent, add 35% of the roof of the wall area to the flat area of the roof. And if the walls are opposite and of equal height, they cancel each other. That's the rule. Yan. So, ito yung table 11-1 from the Revised National Plumbing Code of the Philippines. So, table 11-1, sizing of roof drains and downspout piping for varying rainfall intensities. Quantities are horizontal projected roof area in square meter or the projected. Ayan, tama, projected roof area. Ito, yung total niya. So, item 1 to 12, andito yung mga size niya, rainfall intensity per hour. Ito, ito yun, ito yun. So, ito, schematic diagram of roof drainage system. The scupper is also a drainage yan, ng overflow. Punta dito. Masyadong malakas, hindi na kaya nito. Tapos, natatapon yung iba. Ito pala. So, table 11-1. So, ito rainfall intensity per hour in millimeter. Itong vertical. So, this is the 5 sizes. Diameter of drain. 51 is 2 inches. 76 is 3 inches. 102 is 4 inches. 5 inches. 6 inches. 7 yata to. So, 8 tayo dapat. Okay? So, wala to. Wala to. Meron tayong 8 inches. Wala nang 8 inches na. Hanggang 4 to 6 inches na kaya. 5 inches, di ba? Sabi ko, wala. Yan. Then, sizing of for horizontal rainwater piping. Yung extension na yan, pag mahaba, di ba ito? Yan. Pag masyado mahaba yan, so ito ang gagamitin mo. The size of a building rainwater piping or any its horizontal branches shall be sized in accordance with table 11-2. So yan. Horizontal projected roof area in square meter. Ito naman, doon kanina, sa vertical yung ito, intensity. Tignan, ito pala is a roof plane in downspout. Yung vertical lang. Roof plane tapos downspout na siya. Wala siyang liko-liko. Dito mo siya kukunin. And pag may liko na, tapos mahaba yung liko niya, so dito ka nakukuha. Yan. So dito naman yung rainfall niya, dito ang side. Vertical naman is ang size ng pipe. Kung ako, saan pinagkukuha to? So this is 2 inches. 3 inches waterfall, 5 inches waterfall, 6 inches per hour na rainfall. Normally, dito rin tayo. Ito ang babasahin natin lagi. So, size of pipe in millimeter with slope. Yan. So, itong una is 3 inches yan, 176.2, 4 inches, 5 inches, 6 inches, 8 inches, 10 inches, 11 to 11. 11, 13 yata, dito 12. Salo na malaki. So, yan. So, this is square meter mga area. Pag na-compute mo is below 500, 4 inches, 500 square meter, dito ka na sa 6 inches na downspout. Pag isa lang. So, pag dalawa, tiin mo yung 500, 250. So, di ka pumasok sa 6 inches sa 4 inches ka, 250 ka. So, dito ka sa 1 to 5 inches. So, dalawang 5 inches kung may 5 inches na instead na sa room 6 inches. Or, pwede ka magdawang 6 inches. Kasi yun lang, ang sabi dito is minimum of 1. So, pwede mo tantad doon yung kay aeroplane, yung downspout. Kita niyo yung mga building, di ba tantad ng downspout. This is for 2% slope normally. Yan. Ito yung binabasayan ko ng design, 2% lang yung roof. Meron ding pag 4% yung roof. Yung slope. Slope to ng pipe, ng pipe, hindi ng roof. 2% tayo. Size of pipe in millimeter with the slope. Yan. So, slope ito ng pipe, hindi ng roof. Central pet. So, example 8. Table 11-2B, gamitin natin. Roof area is 548.1 square meter. Maximum rainfall, 127 mm per hour. So, sa example lang ito, sa atin, 102. Philippines. So, pipe laid at 20.9 mm per meter, slope of S is 0.02. So, find the area in column. So, ito yung solution niya. Okay? Yung format natin, pag di ba, given a problem, given required solution. So, yung gayahin to. Siya kaya, hindi naman gumawa, no? Tama, pero sa inyo, lagyan nyo yun ang procedure natin para, kumbaga, pag sinulat nyo yung given, binabasa nyo yung problem. Saka yung required. So, alam nyo yung hinahanap sa problem. Sulat nyo ulit yan. So, size of pipe, maximum rainfall, table 11-2B. Horizontal yan, So, binanggit na 11-2B. 127 mm. Hanapin mo yung 548.1. So, wala dito. Ang next size na is 561.1. Tapos, hanapin mo yung katapat doon, 152.4 mm. So, ang size mo is 6 inches. Ng leader, downspout, saka yung horizontal na branch. Yeah. Pag sa area lang, isa. Isa lang yung nakukuha mo, di ba? Pwede mo sa gawin dalawa, 3, 4, every corner, lagyan mo 6 inches, pwede rin. O recompute mo, hatiin mo sa 4 hanapin mo dito. Sabi mo ng 600, 1/4, 150, so dito siya. So, pili sa lagyan mo ng 4 na 4 inches. Paikot. Or isa lang na 6 inches kung makukuha yung slope. So, pasiguro na lang, gawin mo 4. Para ano man ang slope na mangyari doon, hindi mo pantay yung hook mo. On-the-blade mo sa all sides. Next, sizing of group range. Same pa rin to. So, group gutter na tayo. So, the size of semicircular bottom group gutter shall be based on the maximum group area in accordance with Table 11-3. Itong 11-3A, size of circular bottom, ito yan. Gutter, yung rectangle may equivalent niya dito. Equivalent naman yan. Gutter has semicircular bottom. Depth of equivalent area of rectangular gutter is 0.392 times diameter. Yung diameter, yun na yung width. Tapos yung depth mo is 0.392 times diameter. Yun na yung magiging size. So, table 11-3A is for a slope of 0.005 or 0.5%. The slope of gutter. Ito naman is 0.01% and this is 0.02%. 0.04%. Yan. So, 0.02 tayo. This is diameter of gutter. 3 inches, 4 inches, 5 inches, 6. Alam niya. Sa 51 mm, 76. Convert nyo sa inches yan. Per hour na yan. Inches per hour. So, ito naman yung area. Same procedure. So, ganun din. And. So, example 9. Table 11-3B. Gamitin natin. The group area is 186 square meter. Maximum rainfall per hour is 102 mm. Pipe laid at 104 mm per meter. Slope at S equal to 101. Ang sinasabing pipe dito is yung gutter. Pipe area and column under 102 mm rainfall. Ito yung solusyon niya. Intensity on table 11-3B with S 0.01 and width 181.2. So move to the left and then 178 mm diameter gutter. So if the rainfall is more or less than those shown in table 11-2 and 11-3, then adjust the figures in the 50.8 mm rainfall by multiplying 50.8 mm per hour and dividing the maximum rate of rainfall in millimeters per hour. Ibig sabihin nito, 11-2, 11-3, so wala, sabihin, yung maximum rainfall in millimeters per hour, lampas dito. Dito ang rule. Adjust the figure by multiplying 50.8. Ito sa figure dito, 50.8 is 51 mm. Para yung figure dyan, multiply mo ng 50.8, divide mo na yung millimeters per hour niya. Okay? Bawa, 200 millimeters per hour. Divide mo. Ito example. Example 10. In table 11-2A with 10.4 mm per meter or S is 0.01 and at 203.2 mm rainfall, find the number of square meter 102 mm pipe diameter will carry. Sa table to, yung 50 mm na binanggit dito, ito. Ayan, is 349.3. So sabi niya, so sa solusyon na tayo, multiply mo to ng 50.8, divide mo ng 203.2 is equal to 87.4 meters squared. So, ito na yan. Ang area is 87.4 square meter. Compute mo na, di ba? So, yan. Now, ito pa yung ibang table. Table 11-4, sizing of drain, roof drains, leaders, and vertical rainwater piping. So ito, kung wala siyang horizontal, nag-ano lang siya, pumunugtot lang yung roof drain mo, tapos nagpumunto sa side, tapos babaagan. Wala siyang horizontal, inclination lang. So ito ang gagamitin mo. Okay? Kasi may case na gano'n, may roof drain, tapos dito sa baba. Yung namang roof drain na nag-offset. Offset lang. Pero pag nag-horizontal pa siya, so yung gamitin mo yung 11-3. Tama. Kaya maraming nalilito dito, isang table lang ginagamit. Minsan undersize. So ito yung rainfall, then ice of rain. So meron siyang flow dito. So dito naman, the sizing data for vertical conductors, leaders, and rate is based on the pipe flowing 7/54. Cool. Mabilis to. For rainfall rates other than those listed, determine the allowable roof area by dividing the area given 25 mm a column by the desired rainfall rate. So ito, may mali na naman dito. Di-divide mo siya ng rainfall rate in inches. Hindi yung 150. Bawa ito, 150. Hindi 150. 202 divided by 150. Hindi naman lalabas yan, di ba? So that is 6 inches. 22 divided by 6, lalabas 34. Yan ang correct yan. Kinopya lang nila to. Bibinago to. That's vertical piping may be round, square, or rectangular. A square pipe shall be sized to enclose its equivalent round pipe. Rectangular pipe shall have at least the same cross-sectional area as its equivalent round pipe, except that the ratio of its side dimension shall not exceed 3:1. So far, size of gutter. Parehas lang to. Parehas lang to nung sa unang table. Pero same book. Nagdulo-dubli so ano yun ba? Yan. Ito naman may width siya. 0.8862 times diameter. Sabihin, yung diameter mo yung half depth. Tapos yung ano naman, width mo is 0.8862. Yung kanina, yung isa, depth is equal to ano yung factor to. Yan. 2% naman to, natin. 4%. So, okay. Group base na tayo. No. So roof drains, there are three basic components which form the construction of a roof drain. The strainer, flushing ring, hanapin niyo lang sa figure, combined with a gravel stop required, and rain body or sump. Mushroom or dome strainer should be used for roofs where leaves or other debris may accumulate. Ayun dome. Ayan, ayan pa yan. Volume sump, masaloy niya muna doon bago yung pasok sa pipe. Kasi pag wala itong sump, magkakaroon ka ng very vortex chance. So, pasok. Okay. An open area for drainage is still maintained even though the leaves and debris may clog the lower portion of the strainer. The open area of the strainer should be 1.5 to 2 times the area of the pipe to which it connects. The figure illustrates a typical roof drain. Material. Inside leaders may be cast iron, galvanized steel, galvanized ferrous alloys, brass, copper, or plastic. Actually, any dependable piping material would be satisfactory so long as it complies with the requirements of the local code. Underground storm drainage piping may be cast iron soil pipe with ferrous alloy pipe with clay, concrete by bituminous fiber or asbestos cement depending upon the requirements of the local code. Roof drains may be cast iron, copper, lead, or other acceptable corrosion-resistant material. For velocity, while a minimum of velocity of 2 feet per second is adequate for scoring action in sanitary piping, it has been found that the greater velocity is required for storm water piping. A minimum velocity of 3 feet per second is required to keep the grit, sand, and debris found in the storm water in suspension. Now, pitch roof drainage naman tayo. So, discuss natin yung roof drain. So, kung ilan yung downspout mo, yun din ang roof drain mo. So, pwede ka namang, halimbawa, isa lang yung downspout mo, pwede ka tatlong roof drain. Pag samasamahin mo, pasok mo doon. Basta yung computation mo, minimum of 1. Di ba? Nagtatlo ka ng roof drain, so okay yun. Kasi, above minimum ka. So catchment area or roof drainage, ito yung projected roof area, is the area to be drained within a roof. Catchment area can be a flat or sloping roof surfaces. It also includes vertical surfaces. The effective catchment area for vertical surfaces is single wall shall be 50% of its total surface area up to the maximum exposed height of 33 feet, so 10 meters. Yan lang. Same lang, ito na diniscuss ko doon ng kanina. Ito, iba-ibang klaseng bahay. Roof. Yan. Catchment area of the different roofs. So, effective catchment area. Ito yung gato. Kasama yan. For flat roofs, the area is 8 times EH. Ito, EH. Area ng roof na yan. So, this is the angle of descent of the rain. 26. Ang design value niya is 26 degrees ang angle. Sloping roof, the effective catchment area A, roofing to an eaves or parapet gutter. So ito, sloping roof A is equal to EH plus AB over 2. So area nito plus yung area nitong vertical. Divide by 2. 50%, diba? So, valley gutter, yan, dalawang magkatabi, yan, may isang roof. For valley gutter, one side of the roof will tend to be exposed to the wind and the other will tend to be sheltered. The method of calculating the effective catchment are illustrated in the figure below. So, valley gutter is E is equal to EH1 plus EH2 plus 1 half of AB2 minus AB1. Difference ng height nila. So, runoff from any vertical wall should be added to the effective catchment area. Mga kinumpute mo yan, i-add mo doon. Okay. Later, may example tayo kan. Ito na muna tayo. Storm drain or catch basin. Ang storm drain pipe, storm pipe ang tawag dito. Storm drain. Storm pipe pala. Storm drain pipe. Ito, tapos ito is your catch basin. A catch basin is an underground concrete structure typically fitted with a slatted drain to collect stormwater runoff and route it through the underground pipes. Catch basin can also be used as a junction in a pipe system and may have a solid lead. There are two types. So a type 1 catch basin is a rectangular box with approximate dimension of 3 feet by 2 feet by 5 feet. So type 1 catch basin are utilized when the connected conveyance pipes are less than 18 inches in diameter and the depth from the gate to the bottom of the pipe is less than 5 feet. Yan. Yung slope. Saka yung pipe diameter, maximum. Pag above na dyan, ito na tayo sa type 2. Catch basin, also commonly referred to as storm manhole. So, pag above 18 inches na, or 18 inches and above, kasi wala na binanggit dito equal to 18 inches, di ba? So, less than. So, 18 inches and above, ang tawag doon, manhole. Papasok na kasi ang tao dyan. Catch basins typically provide a storage volume sunk below the outlet pipe to allow sediments and debris to settle out of the stormwater runoff. Some catch basins are also fitted with a spill control device, inverted elbow in outlet pipe, intended to contain large quantities of grease or debris. Catch basins are frequently associated with all stormwater facilities. So ito yung catch basin. Yung actual installation, buti nakakuha ng picture. Lagi siyang normal. Ayan, perpendicular firme yung pipe. Kasi iba kasi pagdating dito, dudrawing yun sa plano, ganyan. So paano may kakabit yun? Titik-tik ka din ng butas pa tabi niya sa catch basin. Ayan, ganito dapat. Bale, makita mo, akala mo above ground siya, pero maglalagay pa yan dito ng buwan. Tatakpan pa yan. Okay. Ito. Alam ko, tatakpan pa to eh. So, ito yung catch basin mo, ito yung downspout mo, leader, then gutter. Yung gutter, butas lang. Okay? Hindi yung pwedeng lagyan ng roof drain na, ano. Saan yung lagay yung roof drain? Yung mga flat. Yung mga, ano yun, so may paglalagyan talaga siya ng roof drain. Ito, butas lang to. Pero kung may space, pwede mo siya lagyan ng roof drain. Pero parang walang space to, butas na lang. Lagyan lang screen. Then, the performance of catch basin is related to the volume in the sump. So that is the storage in the catch basin below the outlet. Lager et al. 1977 described an optimal catch basin sizing criteria, which relate all catch basin dimensions to the diameter of outlet pipe. Dimensions are, the diameter of catch basin should be equal to 4D. Bilog to bilog. So, sa pinakita niya kanina square. So, ibig sabihin, gamitin na natin yung rule na to na ang size ng catch basin is 4 times D. So, may nabasa rin ako PD7 3. So, ano na, basta kasya tong out pipe. At may space ka pa, baka pag-fix niya. Okay? The sump depth should be at least 4D. This depth should be increased if cleaning is infrequent or if the area draining to the catch basin has high sediment load. Tingnan nyo ito, ang ginawa nila, ang babaw. Ganyan lang. So, ito ang kadalasan ginagawa sa atin dito. Mababaw. Kasi wala silang nabasang ganito. Ako rin, yun lang yung ginagawa ko kasi kinupunta ng mga contractor o ano, kasi sanay sila dito. Approve naman, na-approve naman ng mga building official, kaya hindi na mababago yung mga nakasanayan. Yan. Mababaw niyan. Okay. The top of the outlet pipe should be 1.5D from the inlet to the catch basin. O, pwede. Hindi, 1.5. 1 diameter lang to. Pwede rin. Sunod pa. Bagay, tawag dito is optimal. Okay. So, a stormwater pipe needs to be strong enough to carry untreated rainwater. Also, different type of materials that include concrete, brick, or galvanized steel are used to make stormwater pipes. This pipe within concrete reinforced RCP. This pipe drained excess water from the impervious surfaces into the nearby waterways. As different types of material are used, users can choose the one based on their need. When it comes to the most popular material, you can consider reinforced concrete pipe, PVC, SDPP, and SDPE. The material will decide the usability and durability of your radius pipe. So example 11, so determine the size of a storm drain necessary to drain a roof graded 2% slope roof with a general dimension of 20 by 30 meters. Solution. So gamitin natin yung formula. A is equal to AH plus AB over 2 kasi meron siyang slope. So, minsan, negligible na to kasi 2% lang. Pero pag mga above 10%, 15%, 30%, so di mo na pwedeng i-neglect to. So, AB is equal to 0.02 EH. Diba? Same, ano siya. Same width, same length. Same length. AB is equal to 0.02 EH, so 2% slope. So, A is equal to EH plus 0.02 EH over 2. So, is 1.01 EH. So, EH is equal to 20 times 30 is 600 square meter roof area. Equivalent roof area of projected is 600 times 1.01 or 606 square meter. So, table 11 does 2A above under 1% slope of pipe. Gamitin natin. Kasi, check pa natin kasi yung ano. 102 mm per hour. 606 square meter is near 1068.4 square meter roof area, which is served by 203.2 mm pipe or 8 inches. So the size of the pipe is 8 inches. So ito yung size ng storm drain pipe mo. So pag itong size na to, isa lang, para lang to sa roof area 606 square meter. Sample number 12. Area of roof is 10 by 20 is 200 square meter, pitch roof 30 degrees. Solution A is equal to AS plus AB over 2. So A sub B is equal to AS times tangent 30 degrees. So A is equal to ES plus AS times tangent 30 over 2 is 1.29 ES. So makikita mo to sa internet, may mga tables sa diba kung ang 30 degrees, 60 degrees, 45 degrees. Tama yung value ko. Dito yun na-derive. So AS is equal to 200 square meter of roof area. The equivalent roof area is 200 plus 1.29 is 250 square meter. So refer to table 11-4 above kasi sa lecture above. 100 mm rainfall rate. 250 square meter is near 321 square meter. Therefore, specify 100 mm 4 inches downspout. Itong 4 inches downspout, dito lang yung sa side. Diba? Hindi kasama yung kabila. Kasi kabila, kung same size siya, okay lang. Maglagay ka pa ng isa rin doon na downspout. So, 100 mm. Ito yung size, ano ka? 258. So, lampas ka dyan. So, dito ka naman. 321. So, tatapat ka sa 4 inches, 100. Next, however, ito, since the water is to travel 20 meter, so the gutter might overload and there might be a danger of plugging with dirt and leaves. So divide 258 by 2 is 129 square meter. So 129 square meter is near 150 square meter. Therefore, specify 2 pieces of 75 mm or 3 inches pipe. Yeah. . So 150 and tapat niya ay 75 mm. Sabihin, isa dito, isa doon sa kabilang side. So, punta doon yung iba, punta dito. Okay? Kung isang side lang kasi, pwede umakaw siya. Pag malakas na malakas, so pupunta lang, may ipon. Kaya, ano lang, common sense lang. Para kung kailangan mo mag-divide o hindi. Next, table 11-5, the gutter top dimension is 203.2. So, sa gutter dimension naman, top dimension is 260. Ano tayo? 258 na. Okay. So, this is 203.2. So, 8 inches ito. So, this is now example ng roof drainage. Ayan, paikot siya sa dalawang outlet. Downspout. Di ba pumunta dito siyang may horizontal? Kasi dito kasi yung roof drain mo andito. Hang baga, overhang yan. So, ang wall mo andito. So, nag-ano siya dyan. Tapos, bumaba na. Downspout dito. Tapos pupunta sa crack spacing. Yan. So, itong side, dito siya. Kaso, dito yung roof drain niya, papunta doon. Dito bumaba. Kaso, hindi pwede maglagay dito. Iniwasan natin ito kasi pasukan niya. Pangit na. So, dito linagay sa gilid. Sa kailangan pantay-pantay siya. Para perpendicular lagi yung ano mo, yung spacing sa pipe. Yeah? 4 inches ang pipe ko dito. 2 inches yung downspout kasi marami. Yeah. Pwede rin tanggalin tong sa likod. Dalawa dito siya. Pero mas maganda kung meron pa rin dyan. Yung gutter niya, di ba? Okay. So this is the end of this topic. Ito nakita nyo to is yung cast spacing. Lagi. Yan. Makita mo yung mga dito cast spacing na kinakapit natin yung mga ano natin, contactor. Tingnan mo, ang bababaw.